This meeting is being recorded.
Hello, everyone. Thank you so much for joining us today for the AIAA Los Angeles Las Vegas section presentation today. We have a distinguished speaker, Dr. Swati Saxena from NASA AMES in Moffett Field to speak to us about a very exciting program. This event was scheduled actually in November, but because NASA want to review it, so it took a little bit more time. But really highly appreciate Dr. Sasena's effort and to make it happen. And we can chat a bit more in the Q&A. We have a couple of events coming up, but please look into our AIAA membership. One thing I want to mention is Dr. Saxena is our lifetime member. It's really distinguished. She is our loyal member of AIAA. So if you're interested in membership, please look into aiaa.org/join, or you can contact us. We would like you to connect to you, and if you're interested in Los Angeles Las Vegas section volunteering opportunity, please contact me, contact us. Okay, so Dr. Saxena actually gave us a couple of talks before, but anyway, she's currently working as a technical lead at NASA AMES for one of the research programs under NASA's Air Traffic Management Exploration ATM-X initiative. Her research interests include data science for aviation, ATM, computational fluid dynamics, and HPC, high performance computers, and engine icing, turbo machinery, and aeroacoustics. Before joining NASA, Dr. Swati has worked at ANSYS and the GE Global Research Center. She has also held an adjunct faculty position at Santa Clara University. She is a lifetime senior member of AIAA. She has 25 plus technical publications and holds 2 patents. She completed her master's degree and a PhD in aerospace engineering from Pennsylvania State University and completed her undergraduate study from IIT Kanpur in India. So thank you so much, Dr. Saxena. So please, everybody enjoy the talk and bring your question, and we'll have a Q&A after the presentation. Thank you.
Okay, thank you so much for the introduction, Ken, and thank you again for inviting me to give this talk. Every time I presented at this forum, I've really enjoyed this discussion, especially the discussion we have after the presentation. So looking forward to that. And also, if we are out of time today for any reason, please feel free to reach out to me later on as well. We can always have follow-up discussion about the project that I'm going to talk about today and any other related questions. So thank you again for joining. I'm just stopping my video to save some bandwidth. So today, going to talk about one of the sub-projects that I'm technical lead of. It's called Digital Information Platform. In short, we call it DIP. And it's one of the projects within air traffic management exploration project that we have at NASA Aeronautics. So I'll go over, the introduction about the project, how it sits within the overall ARMD, NASA's ARMD organization, what is our research and technology plan as part of this project. We have few field demonstrations planned throughout the project life cycle. So I'll give you an overview of what those are, because that's where really we are looking for partnership opportunities with both small businesses as well as industry to support these field demonstrations and along the way. So I'll go over that in more detail as well. I think Ken already talked about my background, so I'll skip this slide. To give you a better idea of where this project sits within the overall NASA Aeronautics Research Mission Directorate, you can see the flow down here basically. So ARMD has 6 specific thrust areas for next generation research and technology development within NASA. and they span across different areas, as you can see, towards safe, efficient growth in global operations. So that would be related to the air traffic management that I'm going to talk about today. Then commercial supersonic aircraft, you must be aware of several initiatives going on in that area. NASA has been pretty active in uh, developing a supersonic aircraft technology themselves. Ultra efficient commercial vehicles, so testing different uh, ways to reduce fuel consumption, test different alternate fuels, SAFs, and so on. Uh, Safe, quiet, and affordable vertical lift air vehicles is one. In time, SWS assurance, system wide safety, and autonomy for aviation transformation. So these are the big six thrust areas that ARMD currently has. And within those, uh, uh, if we break it down, we come to uh, air space operations and safety, AOSP um, branch, which takes care of all the R&D work going on in the operations and safety of our aviation of the airspace. So within that program, we have a project called ATMX, Air Traffic Management Exploration, and that is what I'm part of. Within the ATMX, we have four sub-projects, and digital information platform is one of them. So this is what I'm currently working on as a technical lead, and we have a team of about, I would say, like 60 plus people who are working on the project. We have a project manager and who oversees the entire project, and it's a big project. It has, we are partnering with airlines and other industry partners as well. So, and as you will see later on with the field demonstrations, there are different um, tasks that are currently going on within DIP. So it's a big team that we have for dedicated for DIP itself. Okay, so just to give you a little bit more background and context to why we are working on this developing this digital information platform for aerospace operations. You might have seen this chart before, but this basically shows how we want to progress and achieve this digital transformation of air traffic management of current NAS, National Airspace System, going from um, the what it's currently is, be it ready, for example, trajectory based optimization, and we basically do a lot of proactive planning. We take into account weather prediction, weather forecast. We want to make sure we are optimizing on the operational cost and efficiency of the overall operations. We want to reduce emissions and so on. But a lot of those constraints and aspects of overall airspace operations are done in silos. So you're optimizing for something, and then it's not like a multi-objective optimization, and still, and there and decisions are made independently, to say. What digital information platform aims for 2035 is the Epoch 4, where we are really looking for collaborative, service-oriented architecture for tailored missions. And it would not only include the commercial um, aviation, which we are currently targeting, but eventually it will open up to other airspace operations as well, with unmanned vehicles, automated vehicles, delivery drones, and so on. So it's developing that collaborative ecosystem, and we want to use this platform as a foundation for that. And by the time we are ready for urban air mobility and delivery drones and so on, we have this infrastructure in place which can be scaled for this collaborative airspace operation. So this is what we are aiming. Now, how the this project started. So it started about 2.5 years back. So it is not a very old project in NASA terminology. And the way it started was we had a RFI um, out in 2019 to collect input from airline operators, airport operators, FAA, and other vendors that we work with, small businesses, and so on, to really see what is the need. Where do they see biggest challenges in terms of their operational needs, what gaps they currently see, and what are their pain points. So we received about 40 responses for that RFI, and we consolidated, we studied all the responses, we consolidated all the input that we got from our stakeholders, and really came up with these five requirements or needs from those RFIs. So first of all, it was clearly evident that the current aviation data is very segregated. It's not easy to access all the complete set of data in a like a simplified manner. So which will lead to like increase access to NAS information, right? So that was one of the common theme that we came to know. Improve data quality. So there is data available from different data sources. FA has their own data feeds. Airline operators have their own data feeds. But we have to, there has to be some kind of authentic kind of source or single source of truth that people will have trust in to get access to that data. These solutions, if we look at if we look at airspace operations currently, there are several models that are out there, both developed by government and also in private industry, to optimize certain aspect of the operations. For example, if you are optimizing your flight route for uh, to avoid certain weather, for avoid turbulence, for example, to avoid certain weather pattern, something like that. So those kind of models still do exist today. They have been adapted for several years, but how do you convert them to reusable solutions? How they can be used as building blocks for something, for another level of decision making. So that's basically another common theme that was realized. Then commercialization methodology. So what really that means is, if once we have these different models and solutions out there, how do we uh, bring this all together and create an ecosystem where you not only have access to these, we are calling these services, you can think of it as um, a software module, right? That does something specific and gives you a prediction or an outcome based on the inputs you give it. So both the services and information. Information means again the data, aviation data that we have access to. How do we bring this together and develop a ecosystem where people can shop for these services and information as well? And then sustainability is definitely a very important topic, and how these services are tailored towards increasing not only the airspace operations efficiency, but also the sustainable, also incorporate solutions that help us achieve the goal of sustainable aviation. So digital reroute, disruption management, trajectory optimization, and so on. So those kind of advanced services, how do we bring all those together? So I spent a lot of time on this slide, but I wanted to give you an idea of how we came to the conclusion of selecting the really focusing on the topics that we have picked for this project. Okay, so once we clearly identified our stakeholders' needs, we decided to build a platform, a digital information platform, which will uh, give us all these benefits that kind of I've highlighted here. And this again goes back to the previous slide, so I'll not spend too much time here. But the objective here is that we will have faster access to integrated aviation data. The services should be easy to search and discover. We should have the architecture should be such that we are able to extend those services, we are able to build on those services, and we are able to scale those services across different airports. They should be reusable. It should be trustworthy information, transparency, and everything should be available for the consumers to look at and make an informed decision. If a service is, we are collecting metrics to monitor the performance of a service, and if that service, so the user can really see if the performance meets their requirements or not, and that's when they can decide they want to use that service or not. And of course, enable services for sustainable aviation operations. So these are our objectives. And to summarize all of this and kind of in a one statement, if we want to give like an objective for this project, so it will come down to accelerate NAS transformation for advanced data-driven digital services to promote efficient aviation operations. So that is what it comes down to. And we are adopting a cloud-based approach so that the system is scalable and readily available and accessible to all the consumers for both the data and for reusable services.
Dr. Saxena,
Yeah.
questions now? Dr. Saxena, I've got a quick question. So just going to your top line there. So this system and this service will be cloud-based, if I'm not mistaken. That is pretty clear. So are we already in the process of talking to commercial providers like Google and like Oracle, or is that still something that will come later on down the project pipeline? Over.
Yeah, so no, that's a good question, and we are using AWS as our cloud provider right now, and so that's the architecture we are using.
Okay, can we go back one chart? I got a question. One chart. So for trusted information, on the lower left-hand quadrant there of your slide, have you guys started discussing or identifying with ASOT, authoritative sources of truth? And with if you guys are with an ASOT, will you create, or do you have a governing body that validate and verify what those authoritative sources are truth are within your community or within your cloud? Does that make sense?
Yes, yeah, it does. And I'm familiar with ASOT and the entire kind of paradigm of how that information is flowing and how do we make sure it's all secure and reliable. So we are talking to FAA about that, and what we are not looking into or touching right now are any of the current FAA policies or standards in terms of collecting that information.
Like
So
NIST would be an example.
yes.
Right? Okay. And I'm sorry, it's just these are same challenges that we're facing at Space Force. So
Yes.
I see some items being mirrored here, and I guess I want to be provocative because these are challenges that we're facing, right? Over.
Right. Right. No, this is a very relevant topic, and we are following FA's guidance in this area to to be honest. Um, if so they have if so they have a data field called swim that they provide access to, so which contains different kind of aviation operation related data, and that's kind of their the ASOT that they look at. We pull in data from swim, from FA swim feed, and add different data feeds to it, and we have come up with an integrated service called Fuser. I can tell you a bit more about that. Now, how to the policies and standards which have to be all the data services that are available on this platform will have to follow those standards, and those are really we are following FA lead on that, and uh, so that's what we are focusing on right now. We are not looking into modifying or updating any of their current uh, standards in terms of data acquisition and kind of formats.
Got it. Got it. Okay. So yes, deferring back to
Yeah,
FA, I kind of I could see that picture a little bit clearer. Okay. Thank you.
thank you. Okay, so to further explain how the platform will work, it's a pictorial representation of the platform, and we've already looked at different components it would bring together. But here, I would just like to explain this picture bottom up to give you more clarity. So data sources, as I mentioned, we are collecting data feeds from different sources, such as FA data feeds for aviation data, from airline operators, as well as weather data. And then we have built a data integration service by combining those. It's called Fuser, and it was built actually pre-dip and as part of another project, ATMX project, and now we have just bought it on the dip platform. So that's just an example of a data integration service. Any other service provider can build their own service and host it on the platform as well. So now this cylinder, the block you see, that's like the common platform we have on cloud. And these blocks are those individual services that will help in airspace operations. And then the customers can be really anybody who is operating their vehicle in airspace, as you can see. So both related to ground operations like runway prediction, as well as air operations like front end applications where you have the service available to the operator, and they are able to suggest a flight reroute or any other change to the schedule depending on the current situation. Of course, we are working hand in hand with FAA and the local air traffic control as well to implement these services. So right
Dr.
now, yeah,
Question.
go ahead, go ahead.
By the way, yes, Rick Garcia again here. Sorry. Dr. So are we currently involving the commercial providers or the commercial customers into these conversations, into these focus groups? An example of that would be like Delta Airlines, Southwest, even some of the foreign international firms, right? Like like the Scandinavian airlines. Are they currently part of the group within these conversations? Over.
Absolutely, absolutely. And we had collaboration opportunity and announcement for collaboration opportunity ACO out specifically for flight operators, that is like commercial airlines last year. We have selected, the selection has already been made for partnering with them. I cannot say the names right now because it's not publicly announced yet. But yes, we are actively talking to the airlines you just mentioned, and they are aware of what we are planning to do, and we continuously seek their feedback and input as we are developing the platform.
Okay, and the only reason I asked the question is we're running into concerns with intellectual property, right? What can be contributed to the system and what could be open source, or what the commercial would want to give, right? There's some information that they might not want to release because it's proprietary and it may affect it's part of their business model, right? Over.
Right. Yes, that's a very important aspect of this kind of ecosystem. And we are aware that these services and data, they can be, proprietary and confidential. So it will be up to the service provider to look at that aspect of their data and services and whatever they can host on the platform and be made, and they will have that choice of whether it's like restricted or we can make this available for use by other airline operators or not. So yeah, all those things will be taken into account.
That's why we have an attorney in the room, right?
Yeah, that's
I've got questions about that, but we'll keep going.
Yeah.
Thank you.
Okay. So yeah, just expanding on this. So on this visual representation, right? So we have two types of opportunities, I would say, to engage with partners and airlines. One is called PS Evals, and it stands for Partner Services Evaluations. And this is where we are really working with airlines and making them, giving them access to the platform, to the early prototype of the platform that we currently have, and they will be able to test the services that we have currently developed and deployed on the platform, provide their feedback, and also look at how if it's adding any value to their day-to-day operations or not, right? So that these are evaluations that will help us guide and develop our platform in to meet their stakeholders' needs. SFNP ops demos, and in a more simpler terms, these are operational demos that are targeted towards sustainable aviation. So we have 4 of these planned along the DIP life cycle, and we have already completed or almost done with the first operational demo. We are currently starting to work on the second one, and the first one I'll go into more detail. The second demo is on developing a service to avoid contrails, which is really a very important topic nowadays towards to reduce climate impact of aviation. Then we have third and fourth demo planned for irregular operations and 4D trajectory optimization that will come a bit later in the future. So 2 ways to engage with partners and operators in this project.
Dr. Saxena, this is Rick. Another question at the top right-hand, you have the flight restriction box, and you have space, the Saturn, looks like a Saturn or there. So are we thinking about spaceports? Are they part of the conversation? Do we have any integrational leads within maybe NASA, or let me even extend that further to maybe like the SpaceX or the North American space flight folks? I've got spaceports popping up in Texas pretty soon. You know that to the spaceport flight restriction kind of areas within FAA. Is there over?
Okay, excellent question. And no, we are not currently talking to SpaceX and on the space side of NASA as well to extend these services for spaceports. But this could be a very good next step of this project. What I'm representing here is really the airspace, the restrictions that are imposed for commercial airspace when, for example, there is a launch happening from Cape Canaveral, and you have like we saw earlier last year with So you have that 2 hour window or 4 hour window where you are not allowed to fly in that space. So adding all those restrictions in your flight planning at the last moment. So that's what's represented here.
Okay, good copy. Thank you.
Yep.
Over.
Okay. So yeah, just expanding on the DIP ecosystem. Uh, as we are, as I mentioned, we have the airline operators, flight operators, US operator applications, and other operator applications for next gen aviation vehicles. So these can all be the users of this platform, and then we have the data source providers, including FAA and service providers. So we are really bringing all the three pillars together here with data providers, service providers to optimize these services or to optimize the airspace operations, and really the consumers for different categories of uh, aviation vehicles. Okay, so I touched upon the field demonstrations and partner service evaluations that we are currently doing as part of DIP. So these are helping us develop the platform and also at the same time get our partner feedback on time to make sure that we are aligned with the stakeholder needs. We also have a university challenge aspect of this project, which is going on in parallel. We are already done with the first university challenge completed in 2021, and I can point you to the outcome of that challenge and what the problem statement was and so on. The second university challenge is going to get live at the end of this month, and that is based on federated learning. So federated learning is an aspect of machine learning where to address your previous point on data security and privacy, uh, airlines sometimes they don't want to share data with the other airlines or outside, and but they still want to use that to build more accurate machine learning models. So federated learning is an approach that can be used there, and I can tell you a bit more about that if we have time, but that's basically the topic we have chosen for the second university challenge. And we have a problem statement that uh, that will be out at the end of the month. Universities will and students will participate in that challenge, and we have some prize money that we will be giving out to the winners as well. Then this is the reference digital information platform, which is basically the core of our project, and the platform that is cloud based, as I mentioned, using AWS. We are developing, and I'll show you a few snapshots to give you an idea of how the platform currently looks. Okay, so to give you a little more detail about the platform itself, it has several features, as you can see here. So it has a catalog where you can register your service or you can look for a particular service, and it will have a lot of information about the service itself, which version it is, what the performance uh, metrics are, and so on. Of course, there is security aspect of it. So we are looking into what would be a good way to authenticate the user and authorize the user once they sign into the platform. The services can be connected or registered to the platform using a API connection, and then there will the platform and service performance will be monitored and reported. So all those reporting and data analytics will be available on the platform. Uh, Talked about the type of services, so data stream, data access, and then on the cloud right now, we have some NASA registered services that we have built for certain predictions. And then as in the next phase, we'll be bringing on board partner services as well. And this is currently available. And this is the part where we are, we're currently working on. And through this partnership agreement, the partners will also be able to register their services.
Dr. Saxena, this is Rick Garcia again. So in the middle tier on the far right, monetization, can you expand on that or provide us an example? Over.
Yes. So data monetization is again a topic that we have started to look into, and we are currently deciding on the technology we want to use there first of all, and then what will be what's our partners' feedback on this concept. So when I say data monetization, I really mean how this is a reference implementation we are working on as NASA. But once the technology matures and it's out in the commercial space, service providers would, for example, want to make money on the services that they are providing. So how would that transaction look like? How can someone pay for their service when they are using their service through the platform? How, or even all the data that's like flowing through the platform and it's going to be available, how can that be monetized? So there are two aspects of it, just purely related to how the aviation data can be leveraged and shared, as well as how the monetary transaction can happen through the platform. So that's what we are looking at within data monetization.
Nice. Okay.
Hey, Doctor, this is Jeremy Robbins. I'm with the FAA. Kind of a follow-on question to that. Are we looking at this, some sort of paid subscription service that the government's going to run? Or is this more like GPS where it's just free to everybody? What's kind of the thought right now? I mean, that might not be decided, but kind of what's the leaning right now?
Yeah, so we are looking into a paid subscription service, and again, NASA will, as a research organization, we will not be charging anything, or the money transaction will not happen through NASA. This is a reference implementation we want to have in place, maybe with a token money or something like that, just to represent that the platform has this capability, and once it's the tech transfer is complete and it's taken up by a commercial entity, they can really use the same mechanism to make these transactions. So subscription based is something that we are looking into. That, yeah.
So Jeremy, it's like me dealing with Bear here and starting a company. Hey, let's start a company and charge a subscription service because the data is here, right? So yeah, we'll go ahead and start an Amazon or Google for this service, Thank you, Dr.
Thank you, Doctor.
Over.
Okay, but yeah, I would say this is still, in early stages of our discussion with partners and of course FAA and others. So we're still down selecting which path we want to go, and specifically as part of the project, when NASA is maintaining it, how far do we want to go along this road? Okay, so these are some more details, but I think in the interest of time, I'll skip some of these technical features on the platform. This just elaborates on the previous slide on some of the distributed architecture, data storage, and API connections that we are building on the platform. But the slides will be shared, so you can have a look in around the different features here. This is just architectural representation of the platform right now. So we have the AWS DIP platform account where you can look at the catalog. There's a catalog user interface which you currently need NASA authentication, go through Access Launchpad authentication to get access to. And this once you become a partner, so that's when we will provide you with the necessary credentials to register on the platform. And also this block here is representing the NASA services which are currently available on the platform, and it consumes or uses the different external data feeds for weather, airlines, and also FAA, and builds or uses that data to build the services, and it's connected to the platform via an API connection. So this can be a non-NASA service as well, and eventually partners will be registering their services through the same mechanism. So this just shows like a high-level representation of the workflow underneath.
Dr. Selena, Rick Garcia here.
Yeah.
Dumb question, but like, where would NOTAMs play into this? Would NOTAMs be part of like an external data feed? Over?
Yeah, NOTAMs can be part of an external data feed. Yeah, if at all we want to make that available on DIP, so it will be something similar to this. Yeah.
Okay. Thank you.
Okay, so as part of our discussion with the stakeholders, we identified few high-value services for the platform, and that's what we have been focusing on and developing within NASA. So I talked about diffuser services. This is basically a integrated data services service. Then, without going into too much detail here, I want to highlight that these are mostly related to optimizing the airport operations, ground operations, and also doing the demand balance. So that's, for example, surface congestion prediction, noise prediction for new entrants. So there are some interesting services that we kind of identified that would be useful for the operators to have on the platform. And with the next collaboration opportunity, we will be looking at service providers who can support the platform with one or more of these services. Okay, so give you a look into the DIP platform that we currently have. So this is what the user interface looks like. And you can see that I have currently logged in with my credentials here. And we have services in different categories. So if you can select these categories, and then those services will show up. Currently, you see NASA logo for all the services because all of them were developed by NASA. We'll change the logos later, but this basically shows, for example, NASA arrival runway service, departure fixed utilization service, departure runway service, and so on. Some of these are machine learning based, and that's where we have really tried to improve from the current status, and we're getting some promising results there. So there are options to register your service, just browse for the existing service, and also connect for support. Okay, so if we click on a particular service, this is what you will currently see. So you'll see the version, how many users are currently using the service, what kind of service it is, like REST API and so on, and then about the service, and also some QoS parameters that we'll be collecting from the service providers. For what's the availability looks like, and what's the response time, and so on, and also performance metrics, so that you know that this if you have two similar services on the platform, you know which one you would like to use. You can compare multiple services. Okay, so the four operational demos that I previously talked about, all related to optimizing operations and infrastructure for sustainable aviation. So these are the four topics that we have selected for these demos. The first one is CDDR. It's collaborative digital departure reroute, basically looking at optimizing ground operations. Here you see a snapshot of a runway and different aircrafts going to a certain schedule to take off from certain runway, and then there's some weather condition that happens, and then how do you reroute it and optimize the ground operations. This is currently underway, and I'll show you some of the results that we have obtained. The contrail avoidance is the next topic that we are starting to look at, and we are actively talking to, again, industry and other and academia who have already worked on this problem in the past and have some models that we can use. Irregular operations management is another topic that we'd like to pick up for the third demo, and the trajectory optimization. So these are the four operational demos that we have planned, and we'll be working with external partners as well to leverage some of the existing capabilities that are there. Okay, so just giving you an example of the first operational demo. We have chosen North Texas Airspace, so Love Field and DFW Airport, to demonstrate this service. And it's the collaborative digital departure rerouting. And to just give you a sense of like what the problem is and what kind of solution we are looking at with the CTDR service, which is again a machine learning based service. I'll go into detail in a second. So there is sometimes, because of certain weather related events, there is this demand capacity imbalance that happens, and that this can result into significant delays. So here you see different departure runways, gates, and if all these flights are now going to depart through this gate, which really leads to this congestion and delay. Now, departure with the CDDR system, we can have enable flight operators to request reroutes and from the air traffic control. And here you can see we can divert some of these flights to different gates and runways to relieve that congestion and have reduction in the departure delays. Okay, so this is one service that we are currently testing in the North Texas area, and we have seen significant benefits. There are two more use cases that we ended up testing with the same service. The first one is recovery from a SWAP event, so severe weather avoidance plan. So what happened in this case is a flight was supposed to go from Dallas to New York, and yellow is the final route that was selected, but red is the swap route that was selected to avoid certain weather event in this area. So this swap route that was initially selected by the operator was around 200 miles longer than the optimal route, and because it was using the south runway and it was avoiding this area, where the weather was building up. With this TOS service, what we ended up doing is um, very close to the departure time, we were able to find adjacent departure gate and file a route that was that will be around 200 miles shorter than the original planned route, and will save on a certain amount of carbon emissions as well as time for the flight. So this not only reduced the surface delay, but also had shorter flight time as compared to the swap route that was initially planned. So this was another use case that we ended up looking at. Then the third use case is the non TMI tactical reroutes, which is basically the situation where the parking gate was closer to the trajectory option set to the toss runway than the filed route runway. So as compared to this, for example, red route, the parking gate was closer to this yellow route physically, where when the flight will be departing. So this again gives us some tactical opportunity to load balance runway demand and use the um, use the existing infrastructure on the airport that to kind of further optimize some of these operations.
Dr. Selena, Rick Garcia, question.
Yeah.
Question has to do with data and data collection. So according to your middle picture there, where we have the country map, does the community and the current architecture, I mean, I guess this implies that the data and the data collection system is already built in, or do we need to concern ourselves with adding new sensors to be able to collect more information? Does that make sense? Over?
Yes, yeah. It makes sense. And the current this service is built on the current data that we have.
Oh,
So we
correct.
don't, so we don't need any additional flight related data or weather related data to make this decision.
Okay, so there's enough in the system and the current architecture supports
Yes.
building model. Okay, good copy. Over. Thanks.
Thank you. Okay, so some of the results that I would like to highlight here from in terms of the savings. So with just by deploying the system, we were able to get these savings between January and September last year in the North Texas area. Fuel savings, emissions, delays, and cost. So it saved us across different aspects, and all contributing to of sustainable operations in a way.
Dr. Selena,
Okay.
Rick, do alternative fuels contribute to this? Identified here? Over.
No, these are all good questions. So these are all on conventional aviation fuel. This is we are not considering SAFs or alternate fuels right now in this study.
Over.
Okay. So I'll quickly go over this. This is more on the logistics side, but it's important that we initially started and tested all this infrastructure in North Texas on NASA network, but now this year and beyond, we will be integrating everything into the cloud, and again to achieve that scalability and distributed architecture, all those aspects, and scale at different other airports as well. So this is in progress. Okay, so I already showed the benefits and the use cases for the CDDR service. Just under the hood, just to give you an idea of what is going on under the hood in that service, we have different machine learning based services for ground operations like configuration, prediction, runway, taxi time, on time, and all those are eventually fed into the overall departure reroute service to give you the optimal prediction that you just saw on a couple of slides back. So these are consuming FA data. These are consuming the fuser data feed I talked about earlier, weather data, and so on, and then giving predictions to optimize the ground operations. Okay, so we skip this slide. This goes into more detail on the machine learning, how we are building the machine learning pipeline, and in the interest of time, but uh, this is something that we'll be sharing later on, so you can have a look. We'll eventually be making these models publicly available. There is already machine learning model available for at this GitHub location, so which can be further, looked at, trained, and so the data is as we are building these models, we keep making them public as well. It's a simple architectural diagram for the machine learning service workflow, the CDDR service that we have. Different types of data storage are available. Data feed is coming in. There are two types of monitors. We have real-time machine learning and long-term machine learning monitor. And at the back end, we have this machine learning training pipeline, cleaning up the data, doing some feature engineering, model building and training, and then model data and model analysis. And this everything is version controlled and so on. So this gives you like a snapshot of how the information and data is flowing in the back end. And it is using supervised learning, one of the classification models, to make runway and taxi time and airport configuration prediction.
Dr. Sawina, this is Rick Garcia. Who's currently running the machine learning effort? Is it under AWS? Over?
So these were all being run on NASA clusters. So it was on-prem. Now it is being ported to AWS. So yes, in FY23, the plan is to be able to run all the models on the cloud and at the other airports as well.
Okay. So I suspect that like in the future, potential service providers would be able to have access to this, right? Over?
Yes, so as far as these machine learning models are concerned, they will be made publicly available for anyone to improve on or use their data set to test and train the models further. Yes.
Okay, good copy. Over. Thank you.
Okay. So an example of the machine learning prediction service performance. I'll just go over just this one arrival runway prediction that we have, and you see the dates on the x-axis, and percentage is basically the percentage of time where the accuracy was what was the prediction accuracy. So this black vertical line is when the machine learning model was deployed. Before that, it was being calculated from the traditional calculations that they had, the models that they had at DFW. So we saw around 7.5% improvement after using the machine learning approach to make predictions. Similarly, for the estimated takeoff time, ETOT prediction as well. This was before and after machine learning deployment. So the deviation went down, the STDs, this is the standard deviation, which should be lower. So that was going in the right direction. So we are seeing some promising results by deploying machine learning. Of course, it has to be further improved. And once we test at other airports, we will see how the machine learning model behaves in other conditions as well.
Dr.
We do, yeah.
You said real world airports. So you guys are actually taking data off of current environments? Over?
Yes.
Oh, nice.
from swim, yeah, FA swim data feed and other data sources. So these are real world data. This is not,
Wow.
yeah,
Oh,
dummy
great.
data.
Great. Over.
We have publications on these learning models and use cases that are published like at AIAA and other conferences. So that those can be provided as well. Okay, so the second topic I want to touch upon is the contrail avoidance service, and then this is something that's currently and this is something they're actively talking to partners about. So I want to just highlight that this is an important one, and if there is some interest and you would like to talk to us about it, let me know. So contrails, as you know, they form because of the ice condensation on the carbon particles in the emissions of the aircraft exhaust. So they act as nuclei, those carbon particles, and then your ice condenses on it. So it impacts climate. There is global warming impact. There's warming impact because of contrails, similar to cirrus clouds, and you can uh, look in the theory and the publications that it has a significant amount of warming because of aviation, because of contrails, if we look at the overall contribution from aviation. So this is becoming an important topic of research, and we would like to avoid contrails if possible. So what we are looking at is developing a reroute option generator and suggestion to avoid contrails. And but to get to this, of course, there's a lot of theory you have to or models you have to look at to first of all predict contrail formation regions, then predict what would be the contrail climate impact because in that region, in that situation, and then come up with an avoidance plan. So we are looking at all these functions. We would like to use if what already exists out there. So some of these models for contrail identification, contrail prediction regions, and so on. And then we can use those as building blocks for this reroute option generator. Once the pre-departure and as well as in flight. Once the flight is in air, we can, and especially for long overhaul flights, we can let the pilot know in advance if we submit the reroute request, even up to like 30 minutes or 1 hour in advance, they should be able to take an alternate route and avoid the contrails. So that's the plan there.
Dr. Serena, Rick Garcia, does NASA or FAA track contrail data by large data, is there a
No.
database that tracks it as current use or what's created? Over?
I'm not sure about FAA, but NASA has been collecting this data through satellite images. So NASA geo satellites 16, 17, they have you can see contrails in those images, and you get those feeds every 1 minute, 5 minute, 10 minute, depending on the geographical regions. So that's one good data set that we have for identifying for detecting contrails. Uh, it's a to answer your question about any real world data set about contrail occurrence, I'm not aware of, but we are discussing about what would be a good way to the sensor on board an aircraft or like a camera, something that kind of tracks that live and provides that data feed.
Okay, good copy. Over. Barrett, we got to start a company.
Yeah.
Build a sensor.
Yeah, we are actively talking about that for how. So it looks like the technology exists, but it's not currently on board. Okay, so I'll wrap up here. There's a lot that I had to cover, so I tried to at least condense it in an hour and give you an high level overview of what all we are working on in this project and how people can partner with us. So through these field demonstration or partner services evaluation demonstrations, we will have a ACO coming up for um, service providers next month, hopefully in February 2023. And there was a ACO for flight operators last year, and we are already in the process of announcing the new partners, which will be some of the commercial airlines, as you can imagine. And we also have a website. I want to post a link here, but I can do that in the chat later. And you can view some of this material there as well and what was shared in our flight operator ACO in case you're interested. So with that, I'll stop and can take few more questions.
Mr. Robinson, I saw you have a question. Do you want to speak out?
Hi there, John Robinson, Cabin Solutions. When you speak of DIP, the current capabilities being deployed to AWS, are you referring to public AWS or GovCloud?
You're referring to the public AWS right now. It's not using GovCloud.
Thank you.
But that is a possibility if the industry would like to go in that direction. But right now we're using commercial.
Any question for folks online? Sean, do you want to say something?
There's quite a few chat messages.
Yeah, is there any questions in chat?
There was, but it's just some. Well, this gentleman has left, so he's not.
I'll ask you a quick question, Doctor. This is Jeremy Robbins.
Yes.
I'm an attorney with the FAA. So I'll definitely get with you later on about the contrails. That's certainly something as an environmental attorney we're super interested in. I was kind of curious, at the FAA, when you say you're talking to the FAA, who at the FAA are you talking to exactly?
Yeah, so we are currently talking to the NextGen organization. Yeah. And contrails, as I mentioned, this is something that we are starting, getting started on. So this will be a topic that we would like to start talking to. I mean, they are already aware of it. They are already aware of our plan, but how how would it be eventually implemented? What would be the incentive for an airline operator to avoid contrails, right? Because they would probably end up burning more fuel. There would be more cost to them for rerouting. So what's the government policy going to be there? How would FAA play a role there? So those are all the questions that we are trying to answer.
Yeah, and then one other quick question for you is for the air carriers. We call them airlines, but anyone who's going to be doing air transportation and that type of thing, are they going to be a requirement that they provide certain data if they link into this system, or is it going to be like the GPS example where they just get it, they pay their subscription fee, they just get data, but there's no requirement on their end to input data? What's the thought process right now? Yes. Everything.
No, so we are not there is no agreement like that. They can only be using the services. They don't have to share any data or commit to any deliverable from their side. That's the current agreement that we have with them. Yeah, if they're welcome to register some of their own data services or provide data, but it's not a requirement.
Thank you.
Doctor, I have one quick question. This is Dan. I'm with the University of Southern California. Is there any chance or hope or discussion about trying to integrate crew duty time as one of the variables in this? So if you reroute somebody, it's probably an edge case, but you don't want to reroute somebody and put them on a flight path that gets them over their duty time by the time they land.
Oh, and add to that noise. Because that's what we say all the time. That's what everyone complains about, noise, not contrast.
Noise. Okay. So what by noise are you referring to, like the aircraft takeoff or landing noise, to airport noise really, or?
I was going with the Dan's thing with the crew rest. Noise is particularly from the routes. We have certain departure routes that we have in place because of noise. Is that something that's all put into place along with the crew rest and all those issues?
Yeah.
I mean, I know all the airlines now do their own crew rest on their own. I don't know if it's practical to make a central database that could be connected to an API, but I didn't know if that was a discussion.
Yeah, that's a interesting point, and I'm not aware of it. If they have such a database and that can be plugged into determining these reroutes. Yeah, that's
a great one.
Yeah, no, that's thank you for bringing it up. I'll see what we currently have, what the current status is. Yeah, and noise is definitely a factor. And if that's the reason a certain departure fix has been selected, then that has to be complied with. So yeah, so the noise envelope that we have around the airport, that those restrictions have to be met.
Yeah, Dr. Saxena, I will send your information to Daniel and send that information to you so we can chat more on the crew rest time. And also, Jeremy. Actually, the Jeremy response is also my feeling, because every time I went to FAA related meeting, it's always noise. That is definitely true. Same people talk about noise all the time. That is true. The contrail, I can tell you, mostly people talking about contrail is people like Dr. Bradley talking about this kind of environmental, fuel efficiency or the carbon zero people. True. There could be other concerns. So I'm just talking about in general.
Right.
NASA must have been serious about it. So they launched the satellite you mentioned to monitor. There must be something very important to do. But I'm just saying, for on the ground, people talk that is true. Noise.
Noise. Okay, no, that's a very good point, and I'll certainly follow up on that, because noise has been a concern. There have been different. So one of the ways we were looking at, and not through this project, but I worked in the past, when an aircraft is taxiing, if it can operate the essential cabin lights and other things on battery, and have the engines in idle mode, or don't need to turn them on until later in the operational setting, so to reduce the noise. So though, yes, noise is definitely, I used to work in acoustics, in the area of acoustics before, so looked at jet noise and so on, how we can reduce that. But overall ground operational noise is an important factor. So then thank you for bringing that up. I'll definitely bring that up in our discussions internally, because we are looking into ideas for the third and fourth field operation demos that I mentioned. And if this is this comes at the top, then we'll basically decide on what kind of feedback we are getting, what are the, to address some of the pain points of the industry.
Yeah, I was just thinking, the classic example of that, Doctor, is when we did Metroplex here at AIAA. Because the computer started to take over more of the routing as far as the arrivals.
Yeah.
The result of that is it was more efficient, but it put everything on the same route. And as a result of that, then the same neighborhood kept getting blasted over again. And so in the interest of being more efficient, it was, but it also created a much more narrower noise band, which then made it much more obvious to the public that there's aircraft all over their heads. So that's just something I just want to make sure you guys are aware of and factoring into your models, especially as you're doing all this machine learning. And then quick question is, like, I'm super excited about this. We're having this exponential growth in aircraft. We have 300,000 general aviation aircraft in the United States right now, 1 million drones. The number of drones is looking to grow exponentially for the next forever. So I'm super excited about the project. I was just kind of the timeline. When are you guys looking at coming up with like a prototype that people can jump on? When is that? What's the thought there? 2035 is a long way away.
Yeah, no. So the DIP timeline, and let me go back to my initial chart. So and people can sign up. So one of the ways I would suggest, if any of you are interested in accessing the platform today, is to submit a response to the ACO that we have coming up at the end of the month, and it is for a service provider ACO. So if you have any service in mind that you think would be relevant for the platform, that's what we are looking for. So going to the timeline chart, we have FY27 when the third demo is planned, and then FY28 is this. So basically, you can think of the DIP life cycle as by FY28, we'll be done with all the demos, and we'll be ready with the tech transfer, and hopefully this will be taken up by a commercial entity at that point, and they'll just run with it. So that's the timeline. We are not 2035 is not when we plan to achieve all of this. Again, the way to get access to the platform is to become a partner, and to become a partner, you can respond to we had the flight operator ACO last year. Now we are coming up with the service provider ACO. So once we are selecting our partners through that process currently. So that's definitely I would encourage you to have a look at the ACO, and I'll post those. Post the link here shortly of our DIP website we have.
Any more questions?
Dan with USC again. Maybe I missed it earlier, but are you using a science data for this at all? Or
the science data, are you referring to some like
the MITRE, where the airlines and corporate operators upload their quick access recorder data up to MITRE, then they can anybody who has access to it can go through that? I don't know if
not currently. I think we're using some weather data feeds that are publicly available. So NOAA weather data, LAMP data feed. Not using science data. I do. Yeah.
Yeah. Okay. Because Dr. Swati actually has to leave at 11:45, so she actually extended. But even more. If anything we can, Los Angeles section, either we can help you for helpful effort to expedite the timeline or something like that. Let me know.
I want to see this tomorrow, not 2028.
So it's work in progress, and we would like to do it in stages. We don't want you to wait until FY28 to get on it. So please have a look at our website. We'll be posting the ACO very soon, and then we are also actually updating our website. So you'll have a much upgraded version in a couple of months with a lot more information and resources there. And again, please feel free to reach out to Ken if you would like to talk on a particular topic, and we can definitely set up a call.
Yeah, definitely. If you want to do some faster demo, or Daniel, Jeremy, they can help out or something. We're happy to do that. To the section, we'll be happy to support you. And the reason I talk about this upcoming event, you can see in the middle, we have an event on February 6th. So Dr. Saxena, if you have time, please join us. This is air mobility. This company is building this air bike stuff. So it's kind of getting popular. Hover.
They call it a hover bike.
Hover bike. So adding more headache for you guys.
I've got all kinds of questions for the company.
Yeah.
People have been flying Chinooks for years. It's kind of like that.
So sorry, Ken, I'll have to.
Thank you so much.
Thank you, Doctor.
Okay.
Thank you.
Yeah, thank you so much for attending. Thank you for all the questions. Yeah.
Thank you. Have a good day. Bye-bye.
You too. Bye-bye.
Bye-bye. For the remaining attendee, our next Saturday, we'll have outreach activity to Da Vinci School, right next to the LA Air Force Base, where Ricky Garcia worked. In case you didn't, Da Vinci School is actually a very good K-12 school. They actually have an emphasis on service people, Air Force, Navy, Army, and they are right next to LA Air Force base on El Segundo, and then right behind Millennium Space System, right across street of Aerospace Corporation.
Yep.
So they're actually in the heart of this South Bay area, so highly aerospace connected. So we finally had the opportunity to have a chance to have a meeting there, and the director will give a talk, short introduction of the school, and also their robotic team will give a presentation. And we also have a group of students from France. Actually, their teacher was in our attendee earlier from France, and they are going to give 5 short talks, very exciting, including electric hybrid cars, electric hybrid aircraft, and also how to use the tidal force between Earth and Moon for propulsion. So it's going to be fun, and we are trying to collect the needs and ideas to help out this educator and students. So then you can see this air mobility, the Hopper event, as Jeremy said, very exciting. And then, actually, I put the wrong picture. You can see the picture.
Yeah, I was going to say, we just did this event.
Yeah, sorry, but the event is correct, but the picture, we put it wrong. It is the annual University Student Branch Mini Conference, which Daniel spoke as a panelist last year. So this year, we'll do it in person in this room. So we have the keynote speaker from Lockheed Martin, Skunk Works. He's also our AIAA fellow. He is the inventor of F-35 VTOL engine.
Oh, wow.
Yeah, he got the Guggenheim Award, very renowned and very distinguished speaker. So he will be here in person. So please join us. And the student, we have UCLA, USC, UCLA, Cal State Long Beach, and UNLV. They're going to tell us their exciting project. And you have a chance to interact with students and to help them, or learn from them.
That's
whatever.
my alma mater, UNLV.
UNLV. Oh, you're UNLV. That's right. And I can tell you, our educator, collegiate chair, the director, Luis, he was a former UNLV student branch chair. So right now have unique union for UNLV folks with Jeremy. Yes, very good. And Barrett is interested in recruiting, help people, finding opportunity, join us. So there's a great opportunity too. Then we also have Dr. Nahum Menemet from Aerospace Corporation. He's going to talk about Aerospace Corporation's effort, opportunity, and also the planetary defense. He's actually our local lead
From the aliens.
Yes, from the aliens. That's what I want to do. We want to build a fleet, Space Force. Exactly. You can annihilate any threat, aliens or asteroid.
The most oversold problem we have.
And then we have another speaker, actually Dennis, who spoke 2 days ago.
Who just spoke?
Yeah, just spoke for Satellite 101. He's going to talk about like a space, the space command, the control center, those kind of things. And but the whole goal is to help the student to know what to expect when they start to work as a professional after graduation. So it's a great actually the student branch are doing very good jobs They build very interesting drones, have built a fly project, and they also have rocket facility for students. USC has
Yeah.
the very exciting
Propulsion lab, yeah.
lab. It's very exciting. Every year, everyone just amazed. We're hoping Cal State, Caltech could join us again last year. If Daniel remember, they have very exciting program, but we don't know yet. So that's a good program. So we have more program coming up, but we're still kind of waiting. That's why I'm chatting with Sean. We might have his presentation and others as well. Okay, so it looks like people are logging out. So anyway, but we are still online here. So thank you so much again. Have a wonderful evening. So see you next time.
Great.
Excellent.
We're going to institute a new rule, Ken.